Okay, hello everyone, welcome to today's stream. And yeah, so it's another wonderful day. And today we'll be looking at Elixir, a wonderful functional programming language. Hey Melody, what's up?
I'm very okay. Hi, Kelechi, how are you doing?
Yeah, I'm good. Just another Saturday.
hmm It is.
So what's up? How's it going at your end?
I can say it's going well. I don't know, it's going well generally. So I'm very excited about today's program. Yeah.
Okay. Okay, cool. So let's jump right in. First, we would, talk about Maka, like new things we learned during the week, and we'd love to share them with you. So, Melody, would you mind giving your Maka, like what you find, what new thing have you learned this week?
Okay, sure. Uh, so I'm going first. Generally,
Yeah.
I think I've been I kind of find interest in the functional programming paradigm, and it's very funny because we're handling Elixir today, and Elixir is a very
Okay.
functional programming language. And I will not talk so much
Yeah.
about Elixir yet, so
Okay.
there are no spoilers. But I
Okay.
think the general idea around functional programming is cool, right? It reduces the ambiguity of. First off, I don't like this in classes. Like the keyword this
Wow.
can be very and binding and all those things. Like you could bind this to the wrong to the wrong thing, and you have you have yourself debugging and debugging. And I think debugging objects OOP is not very straightforward. And
Okay.
sorry, give me.
Okay. Okay. So, yeah.
So functional programming is very straightforward, like next level straightforward,
Okay.
and I really love the straightforwardness and simplicity of functional
Yeah.
programming.
Yeah. Okay, so I think your marker is around functional programming, right? Okay, cool. I love functional programming too. So, but the thing is, let's say, depends on the use case. So, if we're doing things around, depending on what you're building and the way you model the kind of application you're building, right? You might want to use either functional programming and especially the language you're writing. So, if you're the type that's writing like things like C sharp, I think C sharp, most of the way the language itself encourages OOP, object-oriented programming. So but when it comes to things like Elixir, which is your core functional language, you tend to write functions and organize them into modules. All right. So for me, I think my marker this for this jam is the Novo project. Novo, it's an open source project where they're building things to handle notifications. So anyone who has worked on any backend project and front end project, you know that adding notifications can become a hassle. Like you need to make use of WebSockets, socket connection to handle real-time notifications. Well, things like the Novo project, I learned about it when I attended an open source conference in Lagos. So somebody came out, Prosper came out to talk about the Novo project, and then ever since then I started following the project and looking at the way they try to integrate notifications, not just um, in-app notifications, things like notifications through Twilio, like an SMS notifications, as well as email and other sort of notifications. So it's a wonderful project, the Novo team. I think since it's open source, definitely you can build more SDKs to support higher functionalities. All right, so that's my marker, and we'll be jumping in straight to talk about Elixir. So I'm super excited to see how the discussion goes. So Melody, are you ready? Let's jump right in.
Yep, I'm ready. I am ready.
Okay. Okay, cool. Okay, cool. So from the slide here, we're going to the first slide, right?
Yeah, sure.
So the way we're going to do it is first of all we'll learn a bit about Elixir, especially for those who are getting to hear about Elixir for the first time. And then after getting to know how Elixir works and all that, then we'll do like a demo of Elixir code and see how things work with Elixir. All right. So slide one. Melody, do you mind taking this?
Yep. So what is Elixir? Generally, Elixir is a functional programming language. It's a very dynamic functional programming language. And what we mean by dynamic is it doesn't allow you to declare static types before while you're coding them. So it allows you to
Yeah.
write whatever, and Elixir is going to infer the type for you, so you don't have to do that, before you declare it. And
Okay.
said Elixir is a dynamic functional programming language, and it's very heavy in concurrency. It was
Yeah.
created by Joseph Alim, uh, and it was first released in 2011. So Elixir is not fairly very old, but Elixir
Okay.
currently, Elixir runs on Erlang virtual machine. That's the Erlang VM, which has been existing for like a long time, like various decades. Erlang
Okay.
has been existing for various decades, and we'll talk about
Yeah.
Erlang in a few bits. So Elixir is very scalable, right? It's
Okay.
very performant and highly concurrent. And one of the reasons
Yeah.
people love Elixir, irrespective of its scalability and everything, is its fault tolerance. So
Okay.
Elixir, Elixir has this thing called like each connection to an Elixir instance is a process, right? So it uses
Okay.
processes, and that way you have this separation of concern kind of where each process is connected to this server instance, and when that process crashes, so
Yeah.
the you could have supervisors supervising each processes, right? So when a process
Yeah.
crashes, the supervisor is like, okay, there's well, we have a fault here. Please respin another process, and a different process is respond to it to kind of replace that process. And you could have
Okay.
inter-process communication as well, which is very cool. So you could have processes talking to each other and all those
Yeah.
things. And
You
so
already
generally,
explained
what
it,
Kubernetes
Elixir.
does,
Yeah. You're already
yeah,
going way too
I'm
far.
sorry, yeah.
But
So
this is
I'm very,
it's good.
I think I have this next level love for Elixir, and it makes me
Okay.
like like I just embrace the entire ecosystem. So generally, that's all. What Elixir is just a functional programming language, and it's very scalable,
Okay.
very
Okay.
fault tolerant, and heavily concurrent.
Okay. So to add to that, like first of all, I'll be acting like a newbie here, just getting here in Elixir for the first time. So when you say Elixir is dynamic in nature. So it means like, usually when you're in a statically typed language, which is like C sharp or like Java, where you get to declare a type and you get to say what type that variable should hold. Rather, you declare a variable and you're trying to say what you have to declare what type that variable should hold. All right. But in this case, in Elixir's case, when you whatever you assign to that variable becomes what the type of that variable becomes, right? Just like it is in JavaScript, right? So
Yep.
that's its dynamic type nature, right? Okay, another thing is it was created by Joseph Alain in 2011. Wow, that's cool. Knowing that, though some persons actually don't like dynamically typed language, they prefer because of bugs and issues. But since Elixir is a compiled language, I don't know, you might likely catch that though. Let's see. Okay, so we'll just move on to the next slide. So why not just use Erlang? Okay. So
Okay.
so let's see why we
Now,
shouldn't
why
use.
not just so if Elixir?
Yeah.
Yeah, I think.
Can you hear me? Okay, so I think we're having a bit of an issue trying to hear Melody. Melody, are you there? Can
Okay,
you hear
sorry
me?
about that. I usually have a ping server running, and my ping server is like spiking right now. So
Okay, okay,
I'm
okay. Just
always
continue.
very inconsistent.
Okay.
Yeah. So why not just use Erlang? So Elixir was built under Erlang virtual machine, and it means Elixir inherits almost everything the Erlang ecosystem has. And we know that Erlang is Erlang is what your in back then your telecommunications system was built on Erlang, and the rationale around Erlang was that, well, we want a system that doesn't really fail, or that has
Okay.
this next level fault tolerance. So, for instance, if I'm on the line right now calling Kelechi, I don't want the system of the user B or some other person calling Michael to crash, right? So I want this separation of concern, and it still brings us to the to what we have, or the processes we have. So each communication system, each connection to Kelechi should be a process, right?
Okay.
And when that process fails, it shouldn't affect any other thing, right? So
Yeah.
Erlang is heavily concurrent, and it has this next level of separation of concern. So there are supervisors supervising each state and stuff like that. So Erlang has this crazy and beauty under it. And
Yeah.
well, Joseph Ali was like, oh, this Erlang is very cool. And almost nobody writes Erlang these days, right? I mean, if you have to
Yeah.
find engineers that write Erlang, you have to really look deep. People that have like that are very explicit in what they are looking for and stuff like that. So Erlang is not a very why not just use Erlang, right? So the next can we move to the next slide and look at why
Okay.
I think we are even in this third slide, right?
Okay. So before
This
we,
this scale
okay.
did you scale a slide or do you skip a slide?
No, 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 no. I think we're actually on the
Yeah,
fourth one.
I think you did. You did,
Okay.
right?
Okay.
So can you go back to the slide two or something?
Okay. So this
Oh,
is
you
slide
didn't.
two.
Oh, you
Yeah.
didn't. I think it's just me then. So,
Okay.
why not just use Erlang? Well, if you look at it this way, Elixir has a very friendly syntax. So, the Erlang
Mm.
syntax is not friendly at all. It's just not friendly at all. So, has a more friendly syntax, right? And the community around Erlang, the Erlang community is not as robust. Like because it doesn't have a very friendly syntax, people are scared of joining the Erlang uh, community. Coming to
Yeah.
write Erlang code and use Erlang. And Erlang has been existing for a long time, so it means that well, you need to really find very specific people who have specific knowledge about your Erlang issues and problems, right? But Elixir
Yeah.
is like, well, this is not very friendly. However, it has this beauty of it, this beauty in it. So
Yeah.
I'm going to extract it because
Yeah.
Elixir was inspired by Ruby. I'm going to use a similar syntax Ruby has, and I'm going to give it to
Yeah.
you. So you have a more friendly ecosystem, and
Okay.
you can do all your Erlang stuffs. So you can Elixir
Okay.
can has a compatibility with Erlang. It can inherit all the Erlang modules. So you can call Erlang modules from Elixir without doing any
Yeah.
crazy because Elixir already runs on Erlang. So you can just call the Erlang
Yeah.
modules on Elixir. So everything you have on Erlang is existing in Elixir. You just have to say Erlang dots and you can call the modules in Elixir. It's that simple. Like there's no
Okay.
craziness to it. So you already have the Erlang ecosystem at your fingertips in Elixir. So
Okay.
why not just use it because
Okay.
it has a more syntax? Elixir also
Oh, okay.
supports metaprogramming and macros, right? So metaprogramming is generally, let's just see it as a in a high level language, you say code that writes code,
Yeah.
right? So you
Okay.
use code, and this code translates to writing code for you. For instance,
Okay.
the Elixir doesn't have a while loop, right?
Yeah.
Elixir is a very functional programming language, and they tend to avoid certain things. So the way they do, the way Elixir does loop is by using recursion, right? So you use
Yeah.
recursion, you call it back, and that condition continues until well that condition is no more. Well, you could use what's the name? The concept of metaprogramming and macros to write your own while loop and use it just as
Yeah.
any while in any language. So funny enough,
Yeah.
I think about 60% of Elixir was written in Elixir. So there are things
Okay.
that don't exist in Elixir, right? Like apart from the key concepts in Elixir and stuff like that, a lot of things was written in Elixir. So if you go to Elixir right now on GitHub, you'll see that well, there's this section for Elixir, and like there's a good average that is for Elixir. We could fire it up and look at it
Yeah.
right now. You can see that there's this good
Okay.
average that is actually for Elixir, written by Elixir. And that is the beauty of meta programming, use of macros
Yeah.
and all that. Yeah,
Okay. Sounds good. So next one. I think you already explained the last
yep,
one. Okay, so all Elixir models
yeah, I
are,
did.
all Elixir has, in fact, it's built on top of Erlang. So Erlang is Erlang was created by Ericsson, right, for the telephone companies, right?
Yep, yep,
Okay, so I can move to the next slide.
yeah, you can.
All right.
Okay, so this is just basically what we're saying. So you could see that the Elixir syntax is very simple. Here you can have IO puts and you have your hello world, and that is how you console the log in Elixir, right? If you're coming from
Okay.
JavaScript, and that's how you print to the console. We have idle inspect if you want to inspect your code and stuff like that and see where your crash is happening and all those things. And you can see here on the right here, we have a macro. These are def loop. So we are kind of calling this loop module. Modules are the way you organize your functions because Elixir is a functional programming language, but then you need a way to organize your functions, right? For instance, you have same performing functions. You could have a function for a mathematical function, right? Or sorry,
Yeah.
a category of mathematical functions, and you want to organize them.
Yeah.
So you organize them in modules, right? And you have a def
Yeah.
modules called loop. So you could put all your loops in there. Here we are defining a macro called y, and there we are
Yeah.
doing our loop thing, right? And you can
Yeah.
see here we are using recursion where we have to call this loop. So loop calls itself until a condition is actually completed. And this is generally meta programming, or this is generally what's the name? Uh, what did we just call it now? That's
Recursion. Is it
macros and
recursion?
meta programming where you have
Micros.
quote
Okay.
and unquote. Yeah. So that's a bit
Okay.
more technical and a bit more in-depth than what we have today. But when you start dealing with macros, you have to quote and unquote your code because generally you're passing in a condition, right? A code, and
Okay.
that code has to be interpreted and stuff like that. So, yeah,
Okay.
this is what you have. And here we have
Okay.
Elixir calling an Erlang module. So you can see that
Okay.
Elixir is not importing Erlang. It's not doing import this crazy, crazy thing from Erlang. Like we have a system.time
Yeah.
in Erlang. And because Elixir runs on Erlang, we could just semicolon, put Erlang.system, and we have the Erlang software or the Erlang
Okay.
in our fingertips, and we can use it.
Okay. 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 So okay, so with this now we see that okay with the Erlang there colon Erlang is it like a module or it's just a syntax whenever you want to call use Erlang modules. So I see like it looks like system time is like a function in Erlang module. So am I getting this correctly? Correct. So
Yeah,
Erlang is like a
yeah, you
module
can
and
see.
system time is a function.
Yeah, it's like a function in Erlang.
Okay. Okay. Yep. So another point here.
Okay, so yeah, another good reason is it's functional. So when you're asking yourself, why should I even learn Elixir? Well, we've mentioned that it supports meta programming, it is heavily
Yeah.
concurrent, it is fault tolerance, and Elixir is a lot of things. But another reason is functional. So remember when I was telling you that I'm very functional programming kind of intrigues me, kind of, you know, it gets me excited. And it is
Yeah.
because of the paradigm around functional programming. And this is
Okay.
because sometimes like the reason we write tests in our code is because well we can't trust ourselves.
Yeah.
We can make a hell lot of mistakes.
Yeah.
And then when you're dealing with very sensitive data, when you're working for
Yeah.
an organization that deals with very sensitive data, your mind
Yeah.
skips every time you raise a PR, right? Every time you make a pull request, and you're like, "Wow,
Yeah.
did I mistakenly, is there any code that is going to probably mutate my data or something like that, or something like that?" The concept around
Yeah.
functional programming is data. There's this data immutability, and this means that
Okay.
well, I have this certainty that I can pass my code around, and it won't be modified implicitly. So that means there's nothing that is going to modify my code without me specifically saying or writing a code that says, please modify
Okay.
this. So I have that guarantee
Okay.
that my code is going to pass around I could pass my code around the
Okay.
universe and it comes back to me, and
Yeah.
I'm very certain this is my code, right? That is one. So,
Okay.
and apart from that, no, I'm not hitting on OOP here because I use OOP a lot. I think I love the architecture around OOP, like the idea that you could actually have classes and you have methods in classes and you could have these different you could have getters and setters or stuff like that. That's beautiful. You could initialize things in your you could use a constructor, have states and track to those states and stuff like that. That is beautiful. But functional programming here is equally very beautiful. And because we're not dealing with data immutability, we don't have to deal with managing this next level global state and stuff like that. So we are dealing
Okay.
with functions are clear and explicit in their doings. For instance, you could have a function that says add number. That function doesn't need
Okay.
to care about some global variable out there to be modified or
Okay.
something. All it does is,
Yeah.
well, you give me an input, I'm going to take an input and spit out an output for you, right? And that is
Yeah.
beautiful already. So you have this clarity on what each function does, and you could see how your code flows. Like Elixir even have something called piping, where you could pipe functions. So when you have a series of piped functions, you could see that your code is coming out from here. The first argument is being sent into this function, and you get this. You're sending it, so you could have a nested pipe of functions, and you clearly see how that code flows in regular ways, or the regular way to do it, you have to nest code. So you have to write a function, call a function inside. So debugging that is headache because you have to then move into that code, look at, okay, what does this do? Oh, this does this. Oh, that's beautiful. Then you move inside. You could spend hours trying to see where the cause of your problem is. But with concepts like piping and stuff like that, which are supported by Lisa, and with concepts like data immutability, which is supposed to be supported by every functional programming language, you have this beauty of your code being very explicit in what they do.
Okay. Okay. Well, I think having functions around is it's cool. Just you need to avoid side effects. All right. So, yep.
So I think we've talked about this a bit or a lot already because of
Yeah, during the
our
course.
emphasizing. Yeah. So what is functional programming language? Well, functional programming language is a coding paradigm. I mean, it's a way of thinking, right? And it's I would say it's a more defined way of thinking, kind of, where your functions tends to kind of avoid side effects. So they won't accept dependencies that would give them side effects, right? And
Okay.
here we have a functional programming language paradigm is treats uh, computation as evaluations of mathematical functions. So we are treating uh, computation as if they are mathematical functions. So in a regular maths, you could have uh, s plus y is equals z. It's as simple as that, right? In your code, you could have add one plus one, and it will spit out two for you, right? There's
Okay.
no there's no outer function that is going to, well, add one plus one, mutate the top level variable that exists in Rwanda or probably somewhere in Nigeria or somewhere. No, we don't we don't do that here. We're just like, get this. If you have this set of variable that is
Okay.
correct and in the shape you want them, spit out,
Yeah.
do this computation for me, and just spit out a result for me, right? So
Okay.
here it emphasizes data immutability, pure functions, and declarative programming styles. So we are very
Okay.
declarative in our programming and in our writing of code. In functional programming,
Okay.
programs are composed of small independent functions that take inputs and produce outputs without side
Okay.
effects. And this is
Okay.
what we
Without side
emphasize.
effect.
Yeah. So
Yeah.
take the inputs, spit out an outputs. Don't
Okay.
there should be no side effects. So yeah,
Okay.
yeah,
Okay.
it's
Cool.
yeah.
So we move on. Okay.
Okay. So one of the reasons we like so yeah the one of the principal inventors of Erlang, which is a very functional programming language, has this saying that the problem with object oriented language is you think you've got a banana, right? Or probably you
Yeah.
want a banana. I could request a banana and I think I've got a banana, but what I've actually got is a gorilla holding a banana. And if I look closer, I could even see a whole forest around the gorilla.
Yeah.
And that is OOP for you, right? And it's
Okay.
very funny and crazy because you could request for one thing and you have this whole object around it, everything coming your way, and you're like, whoa, I didn't request for this. Or you could make one modification and that could modify a different state altogether, some other place. So you could request for something, you could perform a computation with a method, and that is request that can kind of mutate the state of an entire class, and you're like, whoa, what's happening to my data over here? I just requested this, I just use this function. And I think functional programming tends to be explicit in its
Yeah.
composition. So it's like, I'm not going to mutate things for you. I'll just get this data and spit out results for you.
Okay. So I'll just speak a bit about that because I love object-oriented programming a lot. I think depending on how, I think I just see it is like, okay, sometimes some persons tend to do, you want to create a car, you want to do it differently. So like the idea behind object-oriented programming is you model everything as a different object, right? So okay, even though you're getting the whole forest, but you're getting a forest of its own, like that has its own property that can easily be accessed, that can easily be modified. You can change, two should change forest one to something else and forest two to something else, right? So I feel like, well, I know that, okay, functional programming came around before the whole object-oriented programming, but still object-oriented programming comes with its own benefit because of, object-oriented programming comes with this. I think what I enjoy most about object-oriented programming is the ability to encapsulate data and also create an abstraction where
Okay.
there are some modules or some functions, a class can inherit a class, and then I don't need to bother about the class I'm inheriting. I don't need to bother about the implementation logic. I just make use of it. All right. So, but when it comes to function, all my code is divided into huge number of functions. I need to remember which function to call and which function not to call. But when it comes to class, I can just there's already an abstraction. Or I can implement an interface that I can just bind to. I don't need to know about the implementation logic. I don't need to modify it, right? So I think when you look at it from that direction, you see that object-oriented programming is actually solving a problem on its own. All right. So I just feel like it just at the end of the day depends on the how good are you able to use functional programming and how well can you use class or object oriented programming.
Yeah, actually, yeah. It's see, I think my concern is not that functional object oriented programming is bad.
Yeah.
I'm just saying there's a better way to do it. And
Okay.
generally, I think functional programming comes with this. It's not the best. It could not have the best structure in terms of code structure and all that. And OOP comes with, I mean, OOP has been existing for almost since the dawn of time. But
Okay.
the concept of writing your data and having no side effects gives you guarantee when you know
Yeah.
that your functions are on the same instances are bound to produce the same results. And OOP does its own good. And I mean, what I'm generally saying is to use OOP, you have to know OOP.
Okay.
The language doesn't try so much to warn you about certain failures and stuff like that. So there are things you must know. But functional
Yeah.
programming, there's this set of rules. If you don't follow them, well, you won't write the code. Like the code would not. If you're trying to compile your code, probably it's just gonna throw hands on the air and say, "I won't compile this because you're not following the rules."
Okay.
So you could be messing something up in your probably your data. I'm very data specific because data when you mess up data in prod data, then you're screwing your whole life up. So you could be
Yeah.
messing up some data in OOP and you won't even know. The language will not warn you. except probably you have
Yeah.
a library or something that is encapsulating your entire code and telling you that, well, this you're doing is very wrong. Apart from that, you may not know. But functional programming, you're very clear about what you're delivering and what you're doing.
Okay. Let's hope so. Okay. So, oh, sorry, we missed one slide. Okay, so let's look at the benefits of functional programming.
Okay. Benefits of functional programming, data immutability, code clarity
Okay.
and maintainability, right?
Okay.
Your code is very clear. I can emphasize on this. Like I've been I've inherited a very poor code that is very
Okay.
difficult to debug. So every time I inherit a code and it's very poor to debug and manage, I lose my mind, right? So it pains me to see a very poorly structured code that's very difficult. And then what one of the things that contribute to it uh, is well how you code and stuff like that. But I think generally, functional programming tends to take a step further to helping you structure your code better and be
Okay.
able to debug your code and stuff like that. So meta programming, most functional programming languages support meta programming. And with meta programming, if there is a feature you think the language should have, just go ahead and add it, right? We'll
Okay.
allow it as long as you know what you're doing and you can do it well. Just go ahead and add it, and it will be allowed. There's pure
Okay.
functions. So pure functions produce same output for the same inputs, and this is beautiful, right? So you have something that you know that if you pass in a certain amount of data, you're going to get a
Yeah.
particular result, and that doesn't change, right? So there are no side effects. It can be influenced by the state of this in the class or something like that, and that is cool. And
Yeah.
there's most of OOP help or support concurrency, right?
Yeah.
But I think there's an easier management of concurrency in functional
Mm.
programming, and a lot of functional programming languages I've seen are very in support of concurrency. So
Okay.
where you have your code executing side by side, you have you're leveraging the resources you have, your CPUs and everything, and that is beautiful already.
Okay. Good. Good to know of Elixir and functional programming.
So let's get started with Elixir. Uh,
Okay. So,
yep,
well, we're about to look at how we can start programming in Elixir.
yep. I think we have one more slide.
Okay. So,
Yeah. So to get started with Elixir, you have to head over to the Elixir, the Elixir page or web page or website. Uh, Follow the instructions for your local machine, and you know, go ahead and like do your
okay.
necessary installations. And if you have the
Yeah.
installations right, you can run
Yeah.
IES on your terminal, and it will open up
Okay.
the interactive Elixir for you. So go ahead and do
Yeah.
that. And
Okay.
if you have done that, we can get started, right?
Okay, so before we start with Elisa, there's just a comment I want to add on to the stream. So this is something interesting. There's something interesting I learned while going through the Alexa documentation. So they said here, due to their lightweight nature, you can run hundreds of thousands of processes concurrently in the same machine using all the machine resources efficiently. So I've had the opportunity to want to scale servers, and one of the challenging thing is when you get huge amount of users using that server, you either tend to run most scale that server, right? So most times you either adding more RAM as the server runs is a bit challenging. So you want to like scale horizontally or what. So I think Elixir offers you, with what I saw in their documentation, Elixir has the ability to allow you vertically scale easily. So you can add more CPUs, more RAM to the server, and the fact that you can run hundreds of thousands of processes concurrently on the same server is quite good. And also, processes may communicate with other processes running on a different machine. This also offers you the benefits of you can run your applications in a distributed manner where you have processes running on not just one single device or one single machine, but on another machine. So that's super cool. I'm getting to also fall in love with Elixir. All right, so we're already going into the demo.
Yep. I think there was this research that was done around Elixir, and I think the
Yeah.
guys were like, "Oh, let's see how much we can really scale Elixir." We know that Erlang is very scalable. Erlang is,
Yeah.
if you, I think Erlang is what WhatsApp was initially built on, or the basis of WhatsApp, and that's why you see
Okay.
WhatsApp is next level of performance compared to
Okay.
a lot of communication apps there. So the guys in
Okay.
Elixir are like, let's see what we can actually do with Elixir, and let's see how much we can do with Elixir. And they were able to spin up 2 million processes on a single machine,
Yeah.
and it was able to hold. So it's crazy. It's crazy. And the scaling, yeah. So Elixir by default, when you have a machine, and you let's say you have uh, 8 core processors, or so you have probably processor with 8 cores or something like that.
Yeah.
What happens is Elixir by default will use all your resources. So it doesn't allow you to waste resources. It uses all your
Okay.
cores, all your CPUs and stuff like that. And that's why you hear people say Elixir can be heavy. And this is because Elixir tends to maximize
Yeah.
all your resources for best effect. Okay. That being said, I
Okay.
think I'll just go ahead and share. Okay, I was already
Yeah.
sharing my screen, which is very beautiful.
Yeah. So can you zoom in a bit? It's a bit tiny. Can you zoom in?
Yep,
Is there a way to
I
like
will
zoom
do
into your
that.
terminal? Like it's tiny from here.
I'm trying to zoom in, and let's see. So I'm trying to
Yeah.
have these
Just
two
one more
terminal
time.
instances. Okay,
Okay.
how about now?
Yes. I think this is okay. Yeah. Super good. This is okay now. Okay. Can you zoom the second terminal? Hello. Okay. I think we're having some connection issues from Melody's end. Um, hey Melody, can you hear me? Okay. Okay, so I think we're having some connection issues. Um,
Sorry about that. Like my ping just spiked up. I'm very
okay.
sorry about that. Oh, yeah.
Okay, so
So
let's continue.
now we are going to attempt something. So if you have IES, you can open IES
Yeah.
and have the interactive editor. And I'm
Okay.
going to clear this screen. So one thing I'm going to do is just to show you the beauty of Elixir. So I have
Can you
some
zoom in
different
from the
terminals.
second terminal? One of the terminals looks a bit small. Yeah.
Okay. How about now?
Yeah, a bit, just a bit. Zoom in, zoom in. So I think you're just extending it. Is it possible to zoom in the text?
Uh, I think I can improve this test by going to settings and doing some crazy things.
Okay, so
But
we can
that
work
is
with
the
this one
main.
then.
Okay. So
Yep.
now what I'm going to attend is I'm going to open up IES and name them different.
Yep.
So I'm going to open up IES and name them.
Yeah.
I'm going to open up this and name it Melody and name this terminal section Kelechi. So I'm going to do that now.
Okay.
So I'll say IES dash that name. I'm going to say okay dash that S name, and I'm going to say this is melody, and this is going
Okay.
to open up the interactive section as melody for me. I'm going to do the same here,
Okay.
IEX dash dash S name, and have this as, can you see me?
Yeah, I can see you.
Okay, so sorry, you can see my screen, right?
Yeah, I can see your screen. I don't know. Do you have your cursor? Can you type something?
Yep. Can you see my screen?
I don't think so. Are you typing? I only see the terminal where you typed IX dash hyphen
Okay,
name.
let me just reshare that screen, please.
Oh, okay.
Oh yeah.
Okay. So okay. Okay. Hello, Daddy. Are you there?
Yep, I'm here.
Okay. So
Okay, so I have melody here. I'm going to do the same here,
okay.
and I'm going to call this Kelechi. So I have these two instances.
Yeah.
Do I have this correctly? I think we made a mistake, so I'm going to try this again.
Okay.
Dash S name Kelechi, right?
Yeah. Unknown option. I think there's an issue with the option. Is there an issue with the option?
That's
IX. Your hyphen is you had a single hyphen. You need to add maybe
oh,
hyphen.
I think sorry, I have one who have this here. So sorry
Yeah.
about that. Okay, so we are going to
Okay.
clear this,
Yeah.
and so we'll have this. We're going to clear this as well. So
Okay.
one thing, what we could do here is we could write a module, a grid module. So I'm going to do def module,
Yeah.
and I'm going to call a grid module, right?
Yeah.
And do. So this is basic Elixir. Like there's no
Yeah.
biggie to it. I'm going to call def hello, and I could
Yeah.
say do, and this is a function in Elixir. So I've called a module here, and the way you do is you call a module, you write do and end with a do. And we're not really talking about the Elixir syntax, but let's see what Elixir can do, right? And we'll have
Yeah.
do here. So I could say I dot put, and I could say uh, hello from melody, and here I could say I could end this function here, and I could end the
Yeah.
module, and I have this. And why you're seeing this because, well, in Elixir, every function returns something, right? And this is basically returning, a hello and hello here. And this is like, the representation of the hello. Is it the ASCII or what's the name? The hash
Yeah.
the hash representation of a hello, right? So what I could
Yeah.
do from here is I could call this function, right? I could say greet dot get hello. I could close it to the
Okay.
parentheses, or Elixir allows me to actually call this this way. And you can see hello from
Okay.
melody. Then you have an okay. This is basically an
Okay.
atom. Okay. This is called an atom in Elixir, and we have hello from melody. And if I try to do that from Kelechi here, you're going to see if I
Yeah.
call greet dot hello here.
Yeah.
well, we get a crash because, well, these are two different terminal instances, right? And we can't
Yeah.
actually call this way. So one thing I could do is I could spawn this process from here, right? So let's do that.
Yeah.
Let's do that. I'll say node.spawn, and here I could spawn this. So I could do this and call the melody, this melody terminal name. So this melody here, melody that will ever copy this and come here and paste it. And now in there, I have a second option to provide a second argument. And what I will do is I'll provide a function, right? And this is syntactic sugar for a function in Elixir. So you could do a
Yeah.
function this way. You could call greets. So I'm just firing up a function called uh, greets dot hello, and I am going to remember you can always close this or you don't. You can leave that optional, and I'll end this. These are syntactically you could call this you could call function this way in Elixir. And if I fire all this up, you can see that we have this hello from melody. So
Okay.
this is next level already. So you could do interprocess communication, gRPC and other stuffs are supported in Elixir by default,
Okay.
right? And yeah, you can see
Okay.
that now we have this from here. So you could do remote calls, you could do distributed systems, and that's why one of the reasons people say Elixir is very distributed, a distributed
Okay.
code or software system. You see, you can have something like this and share data, and you have your gRPC and everything uh, inside
Okay.
Elixir by default, right?
Okay, I think that's cool. What you just shared with us now just shows how first of all how we can run Elixir from the IEX terminal. I think IEX is Elixir's repo, that is repeat print eval, that is repeat eval print loop. So you can run Elixir in the terminal, and then this I think when you this can be used to run application distributedly. So I can automatically call a service from another machine, call a function. I don't need to make an API request. I can automatically call a function from a different service or on a different server without implementing gRPC, without using GraphQL or doing anything REST. Well, that's cool. Yeah.
Yeah, that's cool. So
Yep.
sorry if you if I'm looking this way. I think my screen, that's the screen I see you from, is this way,
Yeah.
and I have my screen, my major screen this way. So if I'm looking this way, I'm
Okay.
looking at you. If I'm looking this way, I'm looking at my
Okay.
screen.
Okay.
Yeah.
That's good. So I think we've come to the end of the stream today. Melody, do you have anything, any final say on Elixir?
I think I could have we could share something, right? We could see one of the things or how beautiful Elisa can be. So we could just I think I
Okay.
have some local project somewhere I could just spin up and we look at how how beautiful the Elisa code can be and see how
Okay.
we can if that can intrigue you and probably convince you to come into writing Elisa. So I'm gonna spin up
Okay.
an instance right now. So I'm gonna close these sections because they were used for demo. So I'm going to close them.
Okay.
And I have this here. So let me do this. Uh, so I'm going to close this up. Do Let me see an ls. So what I'll do is cancel. I'm going to spin up a VS Code instance here.
Okay.
And here I'm going to zoom in.
Can you bring the VS Code closer?
Yep.
It's looking a bit far. Okay.
So let me do this. Let me zoom in. So mass. Does this look better?
Yeah, zoom in a bit.
I'm going to do that in a bit. Let me just every time I spin up my VS Code, I have this ton of install live on
Plugins.
there, and
Yeah.
no, I'm not going to. So we have this project here. This is just a basic identicon generator. So if you don't know what an identicon
Okay.
is, I'm going to spin up this. So this is an identicon, right? Where
Yeah.
it takes in a string and
Yeah.
creates, and this already exists on GitHub, right? Where you have the picture thingy. So when you create a GitHub account, you can see something like this, and each name has a different identicon generation. So if I have a name called banana, and I want to generate an identity from that, it's going to be
Yeah.
very unique to banana and it's going to be the same,
Okay.
and so on and so forth. And so we are going to see the code that generates this and how we can actually
Okay.
do that. So this is a
Okay.
basic mix project. Mix is like you can still mix as a so you can see mix as your npm in
Like
Node.js
a
and
package manager.
yeah. So here in the libs we have this identicon
So
generator
are you
here.
using a web framework? I know Elixir has the Phoenix framework.
Yeah, we are using mix. Mix is just a package. You can see it as a package manager.
Okay. Okay. Okay.
Yeah,
So
for yeah.
are you using Phoenix, the web framework for Elixir? Are you using it for this project?
No, no, I'm not using Phoenix for this. I'm just using
Oh, okay.
regular
The raw
Mix.
Elixir.
Yeah,
Okay. Okay. Cool.
yeah. Here we have these simple projects, and I know we have about 100 lines of code. So we are going to explain how what it does. So here we have a
Okay.
module called Identicon, the Identicon module,
Okay.
and
Yeah.
in there we have a bunch of functions, private functions and public functions and stuff like that. Here we have the main function, and this is where your magic happens. So your entire code is this, right? Here we just
Yeah.
have all our function calls, and this is very clear because you can see what happens here. We are accepting this main function accepts an input,
Yeah.
and the input, which is this first argument, is piped
Yeah.
into this hash input, which is a function. And whatever the
Okay.
output of this, remember a function in functional programming language, functions always return something. Right? Functions always have
Yeah.
a return. So whenever whatever this returns, is going to be piped into this pick color and so on and so forth. So here we have hash that input. You know that your code is hashing the input, and we are picking the
Yeah.
color from the hashed input. Then we are building a
Yeah.
grid system. We are doing a filter
Yeah.
odd squares. Then we are building a pixel map. Then we are drawing the image and we are saving the image,
Okay.
right? And
Yep.
yeah, so generally you see this. We definitely will not go ahead and explain like everything or what what maps are and stuff like that, or pattern matching is in Elixir and stuff like that. But this is just a basic Elixir code, and you see here is where your magic happens. So you have functions that
Yeah.
call function that returns things and call another function that returns things and call another function. And if I call you into a code base, I could have this in separate files, right? I could have all these in separate files or different places. And I call you and give you this code as an Elixir developer or some other developer. If you see
Yeah.
this, you already know what this code is doing. And the flow of things, how things are flowing from, okay, we are hashing the inputs. What does hash input do? So here we have a hash inputs here, which is definitely hashing. So hash input takes in the input, calls a crypto module, and hashes it with MD5, right?
Okay.
Then it passes it to the binary dot bin to list, right? So whatever
Yeah.
that hash function is coming out from. So the way piping works is, I don't know if you've written in in your in your terminal, for instance, this is
Yeah.
regular Linux. So if you write something
Yeah.
like, let me zoom into this a bit.
Yeah, the way it works, the way piping works, where you could pipe an output to a file, right?
Exactly.
Is it the same
Yeah,
piping?
exactly.
Yep.
So so if you have something like if you are cataloging let's say readme.md, and we could pipe it, we could this is your pipe operator. So we could say grab probably what could be in this readme. So we could grab where is our readme here? So we could grab something like
Installation
Elixir,
or Elixir.
right?
Okay.
So yeah, we could grab uh, Elixir here, and we'll have to do these cards this way.
Okay.
Okay, I think so. We'll have this and we'll have
Yeah,
this
it's
one
coming
and
as
stuff like that.
correct.
So document can be
That's the
generated.
grep.
Yeah, it's coming out correctly. So you can see that here we are grabbing this Elixir here, and
Yeah.
that is how piping works, right? And that same rationale, your Elixir implements it. So wherever is coming through, you're passing it to the as first arguments to your build. So you can see here that hash is the input. Then we are
Yeah.
calling pick color, and pick color does the
Yeah.
same thing. Pick color goes ahead to pick a color. So here we are calling this. This is basic pattern matching, right? We are pattern matching on this. The same way you look at it, you could see pattern matching as something close to destructuring, right? But it is not
Okay.
destructuring, right? So you could have an object of some shape, and in Elixir you could match that same shape, and whatever you call that variable is actually what you get. So you could see it as destructuring in JavaScript. I mean, that's the closest thing you
Okay.
could think of it, right? So here we are building
Okay.
the image. We are calling identical.image, and we are putting it in here, returning this, right? This
Yeah.
is this map or what's the name? That's our map, right? So we are passing it in here, and
Yeah.
then we are building a grid from it, our grid
Okay.
system. You can see here we are calling our grid system. We are assigning this grid.
Yeah.
Then we are calling a hex. This hex here is whatever we match out from it. So we are destructuring
Yeah.
that hex from the input data that is coming through. And we are calling
Yeah.
enum.chunk every. Then we are doing enum.map. Then list.flatten. We are flattening the list. Then we are doing enum.index and other things, all those things and stuff like
Yeah.
that. And I mean, the general idea we're trying to look at is how clear an Elixir code can be. So this is very clear. I mean, this is where our major code
Okay.
is in, and
Okay.
every other thing is just a build of our major code. So functions are very clear in
Okay.
what they do. This function here is not trying to modify an internal state here or trying to inherit. So I'm not kind of assigning a class here and using it here to modify an internal state or something. The function is just very
Okay.
clear. If you give me the right set of inputs, I'm going to spit out the right set of data for you. And that's very simple.
Okay.
So for the beauty of it, let's go ahead and try this code and see if it runs for us. Sorry, my alarms are going crazy. So let's try and run this code and see if it works out for us. So we can go ahead and compile this. I think we have it compiled here. So I'm going to zoom into this, clear this, zoom into this. Okay. Okay. So I could so let's go ahead and compile this. So I'll compile the
Can you
identical,
use your the
compile.
terminal in VS Code? I think that should show properly. Is it possible we use the terminal in VS Code?
Yep, I think it is possible.
Okay.
So
So
yep. So I could say IEX dash S and sorry. Okay, sorry. It's so we'll have this, we'll clear this. So because this is a mixed project, then we could compile let's compile the identical.ex and see.
okay,
Okay,
one does not exist.
does it say we should compile the identical like this? Awesome.
Okay.
Okay, I think we
We're
have a
having
bug here,
an issue here.
and I can go
Okay.
ahead and start the bug.
So do
Yeah,
you
I'm
mind
trying to
saving the
compile the
file? I don't know. I'm
identical.
seeing a. Can you save the file?
Yeah, it's saved already. I think we've saved it
Okay.
already. So if I do something like this, let me see. Uh, identical, okay, dot main. So I could call main. And what you're seeing here is what you're seeing. This one you're seeing here is just basically an arity. So in Elixir, Elixir deals with arities a lot. You could have two functions with the same name but different arities. So arities are like
Oh,
their arguments, right? A function could have two arguments. A main could have two
yeah.
arguments. You could have another main. So I could come here, do something like this. So let me just close this for a bit. Let me just this for a bit. And so I could have a different main, say def main that has two arities. So I could say A and B, and this is going to work very well. This is
Wow.
valid code in Elixir. So Elixir, you could
Yeah.
see that this is a binary part that has three arities, and you could see this is a binary slice that has two arities, and this one has one arity. So they are not the same thing. These are two different
Yeah.
code doing two different things. So
Okay.
that's just
But
an
they're having the
FYI.
same name.
Yeah, they
Okay.
could have the same
Okay.
name but different arities. So
Okay.
in here, I could call, let's say Kelechi, uh, so let's say Kelechi, right? Because you see that this main here accepts an input, and that input is a
Yeah.
string, right? So let's say Kelechi. And you can see here in this, in our generated files here, there's no Kelechi here. So let's call this
Okay.
and see if that works for us. Okay, and now Kelechi is generated. If I open it up, so this is Kelechi.
Wow. Okay. So that's my
Yeah,
identical.
yeah.
Okay.
So I could call Melody as we have Melody already. I could call something else. I
Okay.
could call Andrew.
Like Sandra.
Just an FYI. Okay, this is Melody, and let's see the consistency. So you can see this is Melody. I'll go ahead and delete
Yeah.
this Melody. So I'm going to delete it and call another Melody. So I'm going to call Melody.
Okay.
Okay, and we'll have that generated, and it's still the same thing. So identicals are
Oh, I
basically
see.
identifiers from your name. So when you have the same change, you're going to have the same attributes and stuff like that. And I think
Oh,
that's just
okay.
a basic
Okay.
demo of Elixir and how fun it can be. I mean, there are a lot of things we
Wow,
could talk about, but
that's
yeah,
that's cool. I'm already blown away by the syntax, but to be honest, it's just when you look at I think when you look at what Elixir can do, then definitely it's something you want to look into and see when you're looking at building robust system that can handle massive number of users, and you're not sleeping and you're sleeping with one eye open with the system crash. I think Elixir can never crash or something like that. They say that Elixir can never crash. Am I correct? A process
yeah,
can fail,
yeah. Elixir has
but Elixir
yeah,
itself cannot
yeah. Elixir
crash.
has crazy fault tolerance. Yeah, it has crazy fault tolerance. So what it means is this: a process
Okay.
could fail, just like Kubernetes, right? Kubernetes pods could die, and other ones
Yeah.
get respawn in its place. That's generally Elixir, and I think that's the
Okay.
rationale Kubernetes is using. So, process could fail,
Okay.
but the like your
Yeah.
server could be running and a process will fail for a
Yeah.
particular user. Other users are using
Yeah.
that same server, hitting that same server, probably using some other service.
Yeah.
So a piece of code could be
Okay.
having an issue, or data could be causing an issue in a piece of code. So another user
Yeah.
connecting to that server is totally working for him, but that user's process
Okay.
has died. And
Yeah.
if you write good supervisors, if you write good code and stuff like that, processes get respawn in this place, and that user is having a
Okay.
new connection, and they can keep working.
Wow.
Yeah,
As
and I
opposed to
think that's
Node.js,
generally why
where
you have your communication.
yeah.
Yeah,
Yeah. So you're saying
I
something.
think
I'll just
that's
say
generally why
shortly.
your communication system.
Yeah.
Yeah, that's generally why your communication systems could crash, like your call could go
Okay.
wrong, and you make a
Yeah.
call the next moment, and it's still working for you, right?
Okay. Okay, cool. I think that's with Node.js. Once maybe somebody a user did something that crashed, that did something wrong, the server entirely goes down if you don't manage failures, right? So it doesn't come out of the box. When a process crashes, then everything goes, right? So, but it's good to see that Elixir handles that, and looking forward to see what I can do with Elixir. All right. So, Melody, any final thing to say?
Yes. Apologies for the various banging at my door. Like I think my neighbors, probably the life of the entire neighborhood depends on me right now, and probably everybody's just banging on my door. So apologies for that and
Okay.
my internet. I will do better
Okay.
some other time. So yeah.
Yeah, okay. So I think that's totally fine. We're working as a team to see that CodeJam continually keeps improving and providing better content. We're passionate about this, and it was nice having you. It was nice doing this, and see you all. Thank you.
Yeah. Thank you guys. Bye. Take care.